We had two small homework assignments last night, page 763 and 764 of our textbook. I want to take a look at 763, question number 2 first. This says, what electric field will suspend an oil drop with a mass of 3.2 times 10 to the negative 14 kilograms, has a charge of plus 2e? What does that 2e mean, plus 2e? 2 times what, sorry? 2 times the elementary charge. So the charge of that would be plus 3.2 times 10 to the minus 19 coulombs. This is an oil drop experiment which Millikan used to find the charge of the electron. Remember what he did? He found the charge of multiple oil drops, and he found that each one of them was either 1.6 times 10 to the minus 19 or a multiple of 1.6 times 10 to the minus 19. So we established the elementary charge, the charge of the electron, and then also established that charge is, what's the word? Charge is quantized, right? Just like money is quantized. Okay, we can have a nickel, you can have 5 cents in Canada, or you can have 10 cents or 15 cents, but you can't have 12 cents or you can't have 29 cents in Canada. Charge is quantized. You have an elementary coin, that is a nickel, and you can have a whole number multiple of nickels. You can have 27 nickels or 112 nickels, but you can't have 2.5 nickels. You can't have 12.5 cents. Okay? Money is quantized. Charge is quantized as well. Okay? The elementary coin would be 5 cents. The elementary charge would be 1.6 times 10 to the minus 19. And then, of course, you can have the multiples of that. All right. So this question gives us the charge. Okay? Millikan would have found the charge. We're given the charge this time. It's plus 2e. We want to find the electric field instead of, again, Millikan would have had the electric field, found the charge. We've got the charge. We're finding the electric field. Okay, what's the first step when we have one of these questions? What should we always do when we have one of these Millikan oil drop questions? Draw a picture, yeah. Sometimes, occasionally, it's not going to be helpful to us, but it's never going to hurt us to draw the picture. And usually, it's going to help us to draw that picture. We don't know which way the electric field is. We do know that we have a charge that is plus, that's positive. We do know that because it's suspended, the gravity force has to act down and the electric force has to act up. Agree? Okay, if it wasn't, if those two forces weren't opposing each other, there's no way that we could have this charge or this oil drop being suspended. If they were both acting in the same direction, then it would accelerate downwards because they would both be acting downwards. All right, we don't know which way the electric field is, but we can figure it out now, actually, even before we calculate the number. Tell me, which way is the electric field based on what you see up on the board right now? Bruce? The electric field has to be upward. Right. How do you know that, Bruce? Good. It's a positive particle, and there's a force upward, and we know that a positive particle has to experience an electric force with the field. Remember, I'm positive the force is with the field. So we got a positive particle. We're told, well, if we read between the lines, we're told that the electric force is upward. Since it's a positive particle, force upward, the field also has to be upward. Now let's calculate the magnitude of that field. Let's say that we got Fe balancing Fg, which has to be the case if it's suspended, right? Think back to Unit 2 when we started seeing that word suspended or hovering or balancing, right? Okay, our physics thesaurus, okay, balance, suspend. Okay, two forces have to balance each other. Two forces have to be equal to each other. In this case, it's the electric force, Q times E, equal to the force of gravity, M times G. And usually at this point we solve for Q, but this time because we have it, we're solving for E. So it's mg over Q. The mass here is 3.2 times 10 to the minus 14. Do not use the mass of an electron here. Okay, when we're doing the cathode ray tube, we do use the mass of an electron because that's what we've got. Cathode rays are beams of electrons. But with the Millikan oil drop experiment, we're not doing an experiment with electrons. We're experimenting with oil drops, which gets us information about the electron, but it's not an electron per se. So there's the mass of the oil drop times 9.81 divided by the charge, which plus 2e is 3.2 times 10 to the minus 19 coulombs. When we do that math, it works out to be 9.8 times 10 to the 5 newtons per coulomb. And we've already established, without the need for mathematics, that the electric field is upwards. All right? Okay, you don't draw that diagram, you're probably going to get 9.8 times 10 to the 5 newtons per coulomb. And if this is a multiple choice question, that's going to give you a 50-50 chance of getting it right. Because one of the answers is going to be 9.8 up, and one of them is going to be 9.8 down. Okay, so you don't draw the diagram, okay, you're probably going to get 9.8, and you've got a 50-50 chance of getting it correct. Hey, that's good enough for you, then all right. Okay, to me, a 50-50 chance isn't good enough. Okay, to me, we want a 100% chance of getting it correct, or as close to a 100% chance as we can. So we want to draw that diagram so that we can establish non-mathematically that the field is upwards. All right, let's take a look at page 764, both of these questions in 764, mainly because the answers that they give us in the textbook are incorrect for both of them here. 764 says, what's the net force on a sphere of negative 5e? Okay, that's negative 5 times the elementary charge when it's placed in an electric field that's upwards in a vacuum chamber. All right, so we're saying we want to find the net force. That means that the forces aren't going to balance. There is going to be an acceleration. We don't know what that is, but there is going to be an acceleration. Let's draw the diagram. It's a negative particle. The electric field, we're told, is upward, and we know that gravity is downward. Which way is the electric force acting on this? Nathan, what do you think here? A negative particle, field upwards, electric force is which way? Yes, good. Because the electric field is opposite to the electric force there. Because it's a negative particle, right? Positive particle, the field would be in the same direction as the force. Okay, that's important. When they did their answer key, okay, they had a field upward, and they just automatically made the force upward as well. If it was a positive particle, that would have worked. But a negative particle, it doesn't. All right, let's do our next thing. F net is equal to the sum of the forces. We don't have to do the whole sum of the forces thing if the force is balanced, right? We just set them equal to each other. But if they're not balanced, if there is an acceleration, then we have to do this. Listen, if you're ever unsure, like if the question is ever unclear, okay, then what should you do? Assume that there's a net force, right? Assume this. Okay, if you're not sure, then assume this, because you can still make this work, even if it is balanced, but just more work, that's all. All right, we're looking for the net force, not the acceleration, so I'm going to leave it like that. I'm going to not sub in m times a, but I will sub in QE for the electric force and m times g for the gravitational force. So what do we got here? 5 times the elementary charge. I think that works out to be 8 times 10 to the minus 19. Is that right? 5 times 1.6 times the electric field, which is 1 times 10 to the 5, plus the mass of the oil drop, not the electron, times 9.81. This should be negative because it's down, and so should this. Let's calculate that number now. We get negative 8 times 10 to the negative 19 times 1 times 10 to the 5. Let's press equals, and then let's subtract from that bracket 2 times 10 to the minus 14 times 9.81. Gives me negative 2.762 times 10 to the negative 14, I think it said, to the negative 13 newtons. So we're going to round that negative 2.8 times 10 to the negative 13 newtons. The negative means that it's down, although we already knew that, right? We already knew that it was downward. Nathan told us a few minutes ago that it was downward because we have a field pointing up and it's a negative particle. So just a nice little check here. We get a final answer for a force that's negative, and it's like, oh, okay, yeah, I predicted it was going to be downwards. Sure enough, mathematically, it works out to be that way. So no guarantees that I'm right, but at least it's not contradictory. So at least it's not telling me that I'm wrong. Here. They had 1.2 times 10 to the negative 13. Anybody get that first, 1.2? Yes? So I suspect if you got 1.2, I'm pretty sure that you made the force upward, the electric force upward, positive and negative for the force of gravity. Okay. So be careful of that. Just because a field is upward doesn't mean a force is. Okay. If it's a negative particle, it's opposite. Now, 2, we want to find the acceleration if the direction of the field is reversed. So in question number 2, we've got a field acting downward, gravity acting downward. This time, Nathan, I'm going to pick on you again because I know you know the answer from last time. This time I've got an electric field downward with a negative particle. Which way is the electric force? Good. Opposite to the field. Now, they're not balanced, but I'm not going to worry about the length of them there. I'm going to say F net is equal to Fe plus Fg. I'm going to say ma this time because I'm looking for the acceleration is QE plus mg. The mass here is 2 times 10 to the negative 14 times A equals QE. There's Q times E. This is positive this time, right? Positive because Nathan just told me again the force is upwards. Let's add to that negative 2 times 10 to the negative 14. The gravitational force is downwards, so we're going to make that a negative value. Okay, we solve this, and it is not 14. How do you know, like before I even solve this number to get A, how do I know that this number has to be wrong? Like if this was a multiple choice question with 4 options, and one of them was 14, I would X that out right away. That would be one that I would know would be wrong right away. How? Like I'm not suggesting it's never possible to get 14. It's just in this case, it can't be. Mark? Okay. Yeah, essentially, yes. Yeah. That's the big thing right there. Yeah, that's the big thing right there. If you have gravity acting down by itself, it'll accelerate at 9.81 downwards, right? But we have something not helping gravity. I could get 14 in the first one. In fact, I think that's what it works out to be in the first one. Okay? Because they're both acting down. The electric force is helping gravity. But the electric force here in question number 2 is countering gravity. So if it's countering gravity, then we're going to make the acceleration something less than 9.81 meters per second squared. Okay, what does that work out to be? I want to say like 5 point something, was it? 5.8? Is it positive or negative? Sorry? Is it negative? Okay. So negative 5.8 meters per second squared. We couldn't tell that by our diagram. We just knew that there was forces countering each other, but we didn't know which way the net force acted. Depends on which force is bigger, electric or gravitational force. How many people got negative 5.8 or 5.8 downwards?